Tranquility Base here. The Eagle has landed.
The year was 1969, and NASA had just achieved an incredible accomplishment. They had landed humans on the surface of the moon and brought them back to Earth. And at that time, NASA had some big goals. But the first thing they wanted to do was build something new. They wanted to build what came to be called a space shuttle. And this space shuttle was going to be reusable. It was going to fly 50 or even 100 times each year. It was going to carry both astronauts and cargo into orbit. It was going to return to land like an airplane, and it would be vastly cheaper than any of the existing rockets, maybe 10 to 20%. And it would fly by 1978. So what happened? In 1981, we finally saw the first flight of the space shuttle and the first landing back at Edwards Air Force Base. A new era of spaceflight was born, or at least that's what they told us. In the next 30 years, shuttle would fly 135 times. It never flew more than 9 times a year. Most years it flew much less. It cost many times what expendable rockets would cost. The total program cost was $240 billion, or about $1.7 billion per flight in 2021 dollars. And it killed 14 astronauts in 2 separate accidents. What went wrong? Why didn't we get the cheap reusable launcher that we had hoped for? Why did NASA expose astronauts to flight risks for cargo flights when they were only launching satellites? Why did NASA persist in flying such an expensive and limiting vehicle for so long? And why was the failure to meet flight rate or cost goals ignored? Well, the answer is that shuttle was never about what you thought it was about, or what I thought it was about. It was really about something very different. And to do that, to understand what really went on, we need to understand what the environment was for NASA in 1969. And as I said, NASA had just made this incredible achievement. And they had these big goals. They were going to have space stations, and they were going to have lunar space stations, and bases on the moon, and bases in Mars, and nuclear shuttles between them. It was this big, exciting exploration plan. But there were some real problems with this. The first is that going to the moon was never an exploration goal. It was a political goal. The whole point of going to the moon was to beat the Soviets in space. And that goal was accomplished. That's the goal that NASA was created for. The public really wasn't interested. After the first couple flights, nobody really paid much attention. And in fact, later moon flights were canceled. Apollo 18, Apollo 19, and Apollo 20 never flew. So Apollo was clearly going away. And this new plan looked really, really expensive. And that was a problem for NASA. And in fact, it wasn't really clear what the long-term prognosis was for NASA at all. NASA was created purely to win the moon race. NASA won the moon race. Can make some very good arguments that that's great. Let's shrink it back down and put that money into somewhere else. And this gave NASA a problem. and a problem that if they didn't solve might result in NASA just going away. So to understand what happened around Shuttle, once we know that, we have to understand who the major players are around Shuttle and how decisions got made. Now, the first obvious player is NASA. And this is a chart of most of the NASA centers and facilities around the country at the end of Apollo. And what we notice is that NASA is very much a distributed organization. They do have headquarters, but most of what goes on in these various flight centers. And you can think of these centers or facilities or labs as fairly autonomous. They have their own management, and they have their own guidance. And while HQ does run things, they kind of also don't run things. And also note that these are spread out geographically across the country. So that's NASA. We also have all of the industry that was working on Apollo. And this is a little map I found. This is the large contractors and subcontractors that worked on the Apollo spacecraft. This doesn't show anybody who worked only on the Saturn V or worked on all the ground equipment, the tracking equipment, all of that. That would be separate. And it's fair to note that this blanketed the whole United States. That if there was a company that did something around aerospace or any of these things, they were probably involved in Apollo. Now, the third player, you've probably figured this out. Since we're dealing with government programs, the third player is Congress. Now, I included Congress because Congress ultimately has the power of the purse. They decide where the money goes and what programs it goes for. Now, the executives certainly has a role in that, but it's really much more driven by Congress. So, after Apollo, we have these three groups. We have NASA, we have the aerospace industry, and we have Congress. And if we're going to understand what decisions they made and why they made those decisions, we need to understand what their motivation is. And NASA decisions are mostly made by NASA administrators, not surprising. And their big motivation, their big goal is to have careers. They want to have a long-term career where they can advance in NASA and have a nice job. And this is true for pretty much any management in any organization. This is not unique to NASA. Then in industry, what does industry want? Well, industry wants contracts from the government, but specifically, they want long-term contracts. Now, one of the problems for these companies working on Apollo was they would sign these contracts, and most of these contracts had a lot of research and development in them. And then it turned out that really not that many actual flight items were built. And that's a little problematic. Research and development you might lose money on, and you're hoping to make a lot of money when you actually make the things. But of course, Saturn V Apollo program got canceled. So industry found they did not have all of these long-term contracts that they really would have wanted. So that is their goal. Now, Congress, it's really hard to talk about what Congress wants because it's not a monolithic body. There are a whole bunch of different people, and they all want very different things. They have different passions. But the one thing that is common for Congress people is they want to be reelected. So we can consider that as a common goal or a common incentive for them. So how do these three groups work together? Well, industry, what they want is contracts. Where do those come from? Those contracts come from NASA. How does NASA do those contracts? First of all, how do they decide what to work on and where do they get the money? Well, that money comes from Congress, and Congress actually provides specific direction. They don't just say, NASA, here's a big chunk of money, you figure out how to spend it. They give NASA a bunch of small chunks of money. And they say, this amount will go to the space station, and this amount will go to human spaceflight, and this amount will go to Earth science, and this amount will go to planetary exploration, and so on and so on. So that is what industry gets. Industry gets money. NASA gets money and direction. But what does Congress get out of this? Well, they get a couple things. First of all, remember that NASA has these centers spread out all across the country. And some of those centers lie in either the district or the state for specific Congress people. So NASA can give them jobs. Now, obviously the jobs aren't for the Congress people, but being able to point to those jobs helps those Congress people get reelected. And remember, that's their motivation. Now, industry can also give jobs. And sometimes those industries are near the NASA centers. Sometimes they are somewhere else, perhaps in another district or even another state. But those jobs are also something that Congress can point to, or Congress people can point to. Industry can actually give two more things. First of all, they can give money directly. So Congress people want money to be reelected. Industry can give that to them. And in the old days, around the time of Shuttle, when that was being created, there were some pretty significant limits on how much money they could give. These days, we have political action committees, and guess what? Industry can give a lot of money to specific Congress people. The other useful thing that industry can add to the mix is lobbying. So if NASA wants to do something, they actually can't really go to Congress and lobby for it. At least they can't do it overtly. But industry can go to Congress and say, hey, when you're writing the next budget, we think it would be really great if you did this sort of thing. So lobbying can translate to money direction to NASA, and then that can translate back to contracts for industry. If you know a little about history, back in the 1950s, President Eisenhower talked about something called the military-industrial complex, which was basically cooperation between the military and the industry to give them more power than they probably should have. Here we have the NASA industrial complex, and it's really doing the same thing. So for these sorts of groups, remember we're back in the 1960s, Apollo is going away, NASA may not stick around. What sort of program would be best for these three entities, for NASA, for the industry, and for the Congress people? Well, first of all, it needs to be a big project. Remember, NASA has all of these centers that they would like to keep around. Has to be a big project. And big project, lots of money to go to the contractors. That makes the contractors happy. Lots of jobs for the states of Congress people. So that makes them happy. What's the second thing? Well, a long-term project. And this is really for a couple reasons. The first is that it is hard to get a new project through Congress. It's always difficult to do that. And that means it's a lot of work. Much better to have a long-term project that just keeps going. And further, remember NASA was worried about their existence. What they want is they want to become like many other parts of the US government. They want to get money on an ongoing yearly basis and not really have to fight for it. And maybe it goes up a little, maybe it goes down a little, but they are established as a normal part of the government. And finally, to drive both of the first two, They want it to be publicly interesting. And I think for NASA, that generally means astronauts. So it's much more interesting if you were doing things with astronauts than if you were doing the same thing without astronauts. And to be fair, astronauts also want to fly. So those two things kind of go together. So what were some non-goals? Well, cheap, easy, reliable access to space. This might have been something some people in NASA wanted, but all the incentives are really set around the other things I talked about. Keeping NASA going, running the decision makers' careers so that they can keep being employed. In fact, you can argue that cheap, easy, reliable access to space is a non-goal or an anti-goal for the contractors. Cheap and easy might be less money for them, and it probably means more competition. So they might not get these long-term contracts. They might have to keep fighting for contract renewals, and that is not as easy and it's not as lucrative. So this explains a few things. And before I talk about the individual things, I want to make kind of an overall comment. When you see a group or an organization behaving in ways that you do not understand, it is almost always because the goals and the incentives that are operating inside that organization or group of organizations are not what you think they are. My assumption was always that NASA wanted to build this cheap, reusable, great new thing. That was their main goal, and that was how they would evaluate things. But that just isn't true. So, to go back to the questions I posed earlier, why didn't we get the cheap, rapidly reusable launcher we hoped for? It was never a goal of any of the groups making the decisions. Wasn't the goal of NASA management, wasn't the goal of Congress, and it certainly wasn't the goal of the industry people who had influence on both of those. So, if it's not a goal of a group, guess what? We aren't going to get it. Why did NASA expose astronauts to flight risks for cargo flights? So, very specifically, Challenger was a flight to launch a satellite. And they had other stuff going on, but their main purpose was just to launch a satellite. So why would NASA build something where you ran the risk of losing astronauts? Well, there's a bunch of stuff going on here. The first is that if you are flying astronauts, every flight you take is human spaceflight. Therefore, it's not cargo spaceflight. And therefore, you cannot compare it to cargo launches because everybody knows that human spaceflight is more expensive. If NASA had built Shuttle so that it could operate in a pure cargo mode, then somebody would invariably compare the cost of Shuttle launching satellites to the cost of commercial launchers launching satellites. And that would not be good for NASA. So indeed, NASA built a vehicle that could not be flown as designed without astronauts on board. And they probably could not do satellite deployment without astronauts on board. Now, could the vehicle have been changed to do that? Probably. It was probably within the technical capability of the time, but NASA very clearly decided this was about astronauts. And you can see they got a big benefit from that. Why did NASA persist in flying such an expensive and limiting vehicle for so long? That was 3 decades. Everybody was happy. NASA was happy. Congress people were happy. Industry was happy. There's no reason to change, no reason to try to do something new. A new vehicle would require getting money for a new program. This is really hard to do, and you have to get the money, and you have to have discussions of why the thing you have currently isn't good enough. And invariably, that might lead to, why didn't the thing you currently have do what you said it would do? It also leads to new contract proposals, and the existing companies might not get those contracts. Finally, why was the failure to meet flight rate or cost goals ignored? There are really two things going on here. The first is, it didn't help anybody's goals to point this out. NASA certainly isn't going to point this out. The Congress people and industry aren't going to point this out. So who could point this out? Well, other Congress people could point this out, but they all have their own goals and their own passions, and pointing this out actually makes it harder for them to get the things they want. If you tear down other people's passions, those other people will not cooperate with you. About the only group that will point out these sorts of things is the Government Accountability Office. And you will see GAO reports through the shuttle era and into the current era that are very critical of NASA on specific things. And they will usually drive some sort of subcommittee meeting or a public meeting in Congress, but they almost never lead to big change. And why not? Because it doesn't help anybody's goals to really rock the boat at this point. The other thing that's probably going on here is Congress is very, very used to big military programs that say they will cost a certain amount and do a certain thing, and they always cost more and they always do less. So I think part of this is just an expectation. Nobody expects these sorts of predictions to be accurate. So what does this mean overall? Well, NASA does not achieve meaningful goals in human spaceflight. And by that I mean the kind of goals that space enthusiasts would want to see. Doing new things, doing innovative things. And they don't do this because NASA does not care about meaningful goals. And to be clear, I'm not saying nobody in NASA cares about these things. There are certainly people in NASA who care about this very deeply. The problem is none of the incentives are designed around those meaningful goals. You do not get promoted doing innovative, new, cheaper things. In fact, that may be a career limiting issue. Much easier to just go along, don't rock the boat, and keep going. And that's just NASA. Of course, industry doesn't want you to do meaningful things, and the Congress people don't want you to do new and meaningful things either. So all of those kind of reinforce. So I want to talk about this a little more and talk about maybe a world that things might have been different in. And the assertion at the beginning of Shuttle was that it would be cheap, rapidly reusable. And we have a good analogy for that in aircraft. And I thought about it a bit and decided, the 737 is one of the world's most ubiquitous aircraft. Boeing has built thousands of these. And it was introduced in the 60s, a little bit before Shuttle, but not a ton before Shuttle. And along the way, we've gone through the initial design, the classic, the next generation, and now the somewhat notorious 737 MAX. And the important point here is that Boeing went through a series of different generations, a series of different designs, and each design was an improvement on the last one. And even within these generations, they did improvements along the way. And why does Boeing do this? Well, because they have to. If they want to stay competitive, if they want to keep selling new aircraft, they need to be competitive with their competitors. And so not only was Boeing doing that over this time period, they also introduced 4 new aircraft. So 757, 67, the 777, and the 787 all developed from scratch during this time, along with updating and revising the 747 at the same time. So this is a lot of improvement and change over this period. Now you can say this is 50 or 60 years, but that is a lot of engineering change and a lot of improvement. So what did we see in Shuttle? Okay, so Shuttle first flew in 1981, and it flew for about 30 years. And what is the difference between these two vehicles? Well, answer is almost none. Now, of course, there was the solid rocket booster redesign that came out of Challenger. That was a change. The fuel tank is actually quite a bit changed to be lighter so they can do ISS missions. And there are a bunch of small changes. But as an overall architecture, the shuttle that flew its last flight is identical to the shuttle that flew its first flight. So we saw absolutely no meaningful change over this time period simply because there is no incentive to do it. And in fact, when we got to the end of Shuttle, after Columbia happened, it was pretty clear that Shuttle couldn't fly that much longer. And we got this new thing. We got the Constellation program, and that involved two new rockets. Ares 1, designed as a crew rocket, Ares 5, designed as a cargo rocket. And both of these were shuttle-derived designs. And why were they shuttle-derived designs? Well, they were shuttle-derived designs because the director at the time decreed that all the Constellation things had to be shuttle-derived. So we see, even given a chance to do something fully new, NASA chose to continue the safe and simple approach. That allowed all of the NASA sites that knew how to deal with shuttle components, they can deal with these new things. And that allowed all the contractors building shuttle components to mostly still have ongoing contracts. Things change a little, but there's still a bunch of follow-on contracts there. Now, it turned out Constellation was part of this bigger thing, and when Obama came in 2010, there was a commission that looked at NASA's long-term plans, and they basically said, you do not have enough money to retire Shuttle, to keep operating the ISS, and to do all the things in Constellation. So Constellation got canceled. And that was not very good for the groups that I've talked about. That clearly did not make the shuttle contractors happy. And what we saw, pretty much the same year, we saw this new thing called SLS. And SLS came out of the Space Act of 2010. So it was defined by Congress, and it was defined as a rocket that could launch 130 tons into low Earth orbit. There was actually no real mission assigned to it. There is now, but at the time there was no mission. And NASA did, under a different director, actually looked and said, hey, what is the best way to accomplish this SLS mission? Should we do something with shuttle-derived? Should we do something more like the Saturn V? Should we do something based off current expendable rockets that already exist? And they went through and they did the analysis, and, well, it turns out it actually doesn't matter what came out of the analysis, because the legislation said that it had to be shuttle-derived. So this is Congress very specifically saying, you know, this world that we had for the past 30 years that made everyone happy, we just want to continue it. So that's how we ended up with SLS. That started, the legislation was 2010, NASA started 2014, 2015, something like that. They were supposed to fly 2017, 2018. Here we are in 2021, and maybe SLS will fly next year. It looks possible. The other thing to note, you remember how I said shuttle never met its requirements in terms of flight rate or cost? So there was a very specific requirement in SLS that it be able to launch a specific amount of payload into LEO. Guess what? This current version of SLS, Block 1, doesn't do that. The follow-on version, Block 1B, also doesn't do that. So once again, we're in a state where, you know what, those requirements actually do not matter. And nobody is going to talk about that because that is not the goal. So that is how we've gone from shuttle into SLS kind of seamlessly and ended up with the same sort of program, although there is a significant difference. I sometimes say that the shuttle contractors who were very happy having nice, profitable contracts, making shuttle hardware and flying it, found out that they were actually more happy making SLS hardware and not flying it. And we can see that, the time for SLS, despite being derived off existing components, which was supposed to be quick and fast, is pretty much longer than the time it took to build shuttle from scratch. Not really a surprise. Now, it is true there is one more thing that came out of this time period that is good, and that is commercial resupply. And at the end of shuttle, it was pretty clear that shuttle was going to go away after Columbia. And NASA had a real problem, a significant problem. And that was, how are they going to get cargo and astronauts to the space station? And up till then, they just used shuttle, but shuttle is going away. And it was possible, maybe they were going to use Constellation, maybe they would use Ares 1, but Ares 1 went away as well. And it wasn't going to be a cheap version anyway. So NASA did something very different, and they came up with commercial resupply, essentially a much more normal business relationship, where NASA would say, hey, we want somebody to do this, and who is willing to do that? We'll pay for some of the development. And that gave us Falcon 9 with Dragon and Antares with Cygnus, and that was really successful. It's not the cheapest thing around, but it's a lot cheaper than shuttle was, and it's been good and it's been reliable. Now, part of what happened as part of the 2010 Space Act that set up SLS, looks like there was a little bit of horse trading there, and we ended up with commercial crew, or what was known as CC-Dev, commercial crew development. And that is applying the same CRS model, but to carrying astronauts as well. And one of the reasons this was so important is that NASA had a very big political problem. And that problem was they had this wonderful space station, and the only way to get astronauts onto it was to send money to the Russian space program and pay for them to launch. That is really, really bad in what they usually call optics. It makes NASA look very, very bad. That we have this great space station, but we can't get to it on their own. So that led to commercial crew development, and that gave us the Crew Dragon on top of the Falcon 9. And that's flown a few times. With any luck, in maybe a year or two, we might see the Boeing Starliner fly on top of Atlas V. And this is not the cheapest thing around. These seats still are quite expensive, but at least it's kind of a move in the right direction and a different way of doing contracts. Doing contracts with companies that are much more driven by the economics of it than they are by trying to have this long-term, easy, comfortable approach. Now, there's an interesting question here. If NASA had decided to do something different, what if they didn't have those constraints? What if they were just trying to be as effective as possible? What might they have done? Well, there's actually this program called X-20 Dinosaur. In the late 50s, it was canceled in the early 60s. Dinosaur was an experimental space plane. If you wanted to build something like the shuttle, it would be nice to work your way up to it. They were going to do this in 3 stages. There was the first version. You put it on top of a Titan 1 launcher. This is suborbital. Titan 2, suborbital, but maybe a little more orbit. And then finally on top of a Titan 3. And that would get you to orbit. So, nice incremental approach. And you could learn a whole lot. And then after you'd gone through this, you could do whatever it made sense to do next. This was somewhat ironically canceled due to high cost and also to NASA's decision to go with Mercury with a capsule-based approach. But this is the kind of thing you would want to do. Build prototypes, fly them, figure out what's going on, go on to something next. But that wasn't big enough. NASA needed, you can see that outline, they needed a big vehicle. And so they chose to do shuttle. Now, in present day, what would you do? Well, we actually have a great example of what you would do, and that's been going on for the last few years at SpaceX's site at Boca Chica in Texas. And SpaceX building Starship is exactly the way you want to do development. And why is SpaceX doing it that way? Well, they have very different incentives. They want to do it fast, they want to do it cheap, and they want to make good progress. They don't have any of the drivers that NASA had around keeping all of this existing infrastructure in place. They aren't concerned about these lucrative projects because this is almost all their own money. And that is why we see SpaceX behaving so fundamentally different than we see NASA behaving. Just have very different incentives. So, I hope that was interesting. Thanks for your attention, and please subscribe.